Let's work problem number 37 from the homework, and it's on page 146 of your textbook. And here's what it is. Actually, does somebody have a, can I borrow your book? Yeah. Just for a second. Thank you. Here's, because your book has bigger text. So here's number 37. So let's read it. It says, a sled of mass 50 kilograms is pulled along flat, snow-covered ground. The static friction coefficient is 0.3, and the kinetic friction coefficient is 0.1. Now, this is really common on snow and ice, that the static coefficient of friction is much greater than the kinetic coefficient of friction. Because once you have kinetic, sometimes you're melting the ice a little bit, get a film of water, it makes things really slippery. So we want to know, what does the sled weigh? What force will be needed to start the sled moving? What force is needed to keep the sled moving at a constant velocity? And once moving, what total force must be applied to the sled to accelerate it at 3 meters per second squared? So I think I'm going to do each one of these as almost like a separate problem. So let's do A. So here's what's given. It says, well, let's write down what's given around. Here's a snow-covered ground, and here's our sled. So let's draw a sled on here. So I just draw sleds as I remember them. There's a place where you sit. Here are the runners. And it said, the mass of the sled is 50 kilograms. And it's pulled along a flat. Now the static coefficient of friction is 0.3. So actually this is being pulled along. So we've got some applied force like this. Now the static coefficient of friction is 0.3. And 3.0. And the kinetic coefficient of friction is much less. It's 0.10. Okay, so that's kind of what's given for part A. And this is the same stuff that we'll use in the other parts of the problem too. So, and then we want to know for A, what does the sled weigh? So basically we want to find mg. So for solving, well, the weight is just equal to mg, so that's just going to be the mass times Earth's gravity field, 9.8 newtons per kilogram. And so this is pretty easy. I think it's 490. So that's the weight of the sled. Now for part B, what are we trying to find? What force will be needed to start the sled moving? So we want FA to start. Now one of the things that they call this static friction, but a coefficient of friction, but I think one way of thinking of that S is the starting coefficient of friction. Because here's what we're gonna solve this now. Now we're gonna draw the free body diagram. Use the procedure to solve the problem. So here's the sled all by itself. And we know that there's an applied force to it. And this is what we want to find. We also know that there's a friction force. And of course we know there's gravity. And there's a normal force. And we'll make this our x and y direction, as we always do. And let's sum the forces in the x direction equals ma in the x. I always do this. Might seem a little tedious, but it really helps. So I look in the x direction. I say, well, it's Fa minus the force of friction equals. Now, what they're really doing, yeah, it's the maximum force of friction before it starts to slide. It's kind of deceptive. This coefficient of friction right here tells you that the maximum possible static friction you can get will be 0.3 times as big as your normal force. And so, but it's actually just before it starts to slide. And if it's just before it starts to slide, it's not accelerating yet. So this is going to be 0. So I'm going to say the applied force is just equal to my force of friction. But my force of friction is equal to the static coefficient of friction times the normal force. Well, in this problem, what is the normal force equal to? It's going to be equal to the weight. Right? So I'm going to put 0.30 times the normal force, but the normal force is equal to the weight, and the weight is 490 newtons. So I can say that the force of, so that the applied force is equal to 490 times 0.3. And that's 147. And that's my answer to part B. Okay. Well, let's do part C. What's given in part C? Part C, it says, what is the force needed to keep the sled moving at a constant velocity? Oh, okay. So for part C, what we want to find is, let me move this over here. We need the applied force, but what are we going to do for that applied force? It's going to be sliding and constant velocity. Now this is really kind of what's given. We're trying to find the applied force when the sled is sliding, but sliding across the snow with constant velocity. So you can cheat a little bit and write it like that. I'm not that much of a fanatic on the given find and solve thing. Well, let's solve for it. Now, I'm not going to redraw the free body diagram because I don't need to. It's the same free body diagram that's down here. So I don't need to repeat that work. And if I sum the forces in the x direction equals ma in the x direction, I'll go ahead and repeat that. So I know that the force of friction the applied force minus the force of friction is going to be equal to 0. There's no acceleration. It says it's moving at constant velocity in part C. So that just means that my applied force, once again, is equal to my force of friction, but that's going to be equal to mu sub k times the normal force. And this is 0.10, and the normal force is 490 newtons. And I don't need a calculator for that. The applied force will be 49 newtons. And that's my answer. Any questions on that one? Now for part D, let's read the problem. What are we trying to find in part D? it says, once moving, what total force must be applied to the sled to accelerate it at 3 meters per second squared? So again, we're going to try to find the applied force, and it's going to be sliding, but now the velocity isn't constant. What do we know? A equals 3 meters per second squared. Now there is an acceleration. Now let's solve this part. I don't need to redraw the free body diagram. It's the same free body diagram for all the problems. So if I sum the forces in the x direction equals ma in the x direction. Now what are the forces in the x direction? Again, it's just Fa, the applied force, minus my force of friction, equals ma, but now there is an acceleration. It's not constant velocity. It's not motionless. It's accelerating. So that's going to be ma, and that's going to be 50 kilograms times, and the acceleration is 3 meters per second squared. So Fa minus the force of friction. Now it's okay to use your previous problems to take little shortcuts. The force of friction is mu times the normal force. It's 49 newtons, right? Because it's sliding, so that's sliding friction or kinetic friction. So that's 49 newtons equals, now what's 50 times 3? That's 150 newtons. So now I can solve for this, just add 49 to the other side, and I get 199 newtons. And I think I read 200 newtons as the answer, or 20.0 times 10 to the 2. The book rounds everything off very precisely. I'm just going to leave it like that. That's good enough. So here's the whole problem. And notice all the different kinds of problems we can solve. And notice how how I lay this all out. Okay? Now, make sure, hey, I've done this for you. Wait a couple of days and try to do the problem yourself. Because there's a problem just like this one on the exam. If you can do it yourself, you're in great shape. If you can't, you can go back and look at this video and then, review and then study and then wait a day or two and try to do it yourself. Get to the point where you can do these problems by yourself. That is all.